Hey, what's up, everybody? I'm Austin with PDQ.com.
I'm Jordan. We're here to talk about Networking 4.
That's right, Networking 4. What we're going to get into is routing. Everything we've been talking about previous to this is basically switching technologies, and that took about a total of 3 videos. Routing is probably going to take 1 to 2 more, so I'm sorry to disappoint. I hope routing wasn't... everyone in the audience wasn't cheering, standing up on their feet. Yes, routing in 1 video. Let's go.
Well, I was.
But I believe in you, and that's what I appreciate about you.
I was too, but you know.
So what is routing? You know what I mean? Let's really break down the philosophy of routing. No, but really, routing is basically taking in a packet network, taking information in the IP header, basically the destination IP address. When a router gets an ingress on that, it makes a routing decision or a decision on where to send that packet next, right? That is pretty much done on not even routers. Computers do this all the time, right?
So in broad terms, is it better to have fewer routes in the table where it's more general, or is it better to be more specific and fine-tuned?
It really depends on the router you're using. Like if you have it's the resources. If you're a big company and you can afford a big chunky router, then you can afford the entire internet routing table, for both IPv4 and IPv6. But if you've got a small little router, or maybe you're using a catalyst switch as a router, then you can only afford so many prefixes in your routing table.
This is the first I've heard about money making things better in IT.
That's if you can get the money. It always makes it better. It's about, can you approve it?
How much would one of those big chunky routers cost you? Sorry to derail, but I'm curious.
I will gladly look it up because those are easy to find. Is that okay if I do that super quick?
Can we take a question? I guess that's a...
Yeah, we can also take a question, but they're going to cost you upwards of $100,000 for sure.
I was going to say, I think you are taking a question. Yeah. Jake had posed one.
Sorry,
so
yeah,
there you
I was just curious. Like, so okay, we're talking 6 figures then.
Yeah, to bounce off what Paul's saying, Meraki's a great price, like what I would call
bulk
average. You're going to get a great performance for the price. It's pricier than like Ubiquity, but you get more performance out of it, right? But yeah, it depends on your needs. Do you want a lot? Do you mind if you have a lot of prefixes in your routing table? Can your router handle it? You know what I mean?
Okay. So if you have the equipment is good enough, getting specific just makes things run more efficiently. But if you run the risk of things just overloading, I guess.
Yeah, you also, in order to make a routing table less large, you have to be less specific, right? Yeah. Like the ultimate less specific route is a default route, right? Where you'll take any IP address with any subnet. But
I see you got pulled into that comment about ubiquity.
Yeah, sorry. It's a trigger word for me. So I saw it and I froze and I had Vietnam flashbacks. But so what is routing? Like I said, you take the data within an IP header, you use it to make routing decisions or destination decisions, right? So what types of routing do we have? The simplest one is static routing, right? So we can dive into a little bit of static routing here, but static routing is basically within one router creating a static route to a prefix that it's almost per line too. But yeah, let's go ahead and jump into that super quick. So we got our lab here. We've got a few routers. Say hello to the routers. Hello.
Hi.
Hi.
I didn't realize they talked back.
They talk back. They get a little feisty. So let's go ahead. So right now, if we did show IP route, I've done some pre-configuration, which is why you're going to see IP addresses in here. But if I wanted to...
grabbing the right pen, I like it.
Yeah. So these are your... if you do show IP route within Cisco, every network vendor has their own show IP route equivalent. But these are all the routes that you have right here, right? We can identify what kind of routes are what based off of the codes to our farthest left. So you see how we have like a C and an L on the far left. I'll try to highlight that. Yeah. Oh, I totally missed.
You're in the vicinity.
That's all right. So the C and L up here, you can identify that, hey, C is for connected. Oh, sorry. yeah. Anyways, it's a quick identifier to tell you how that route was learned, right?
So
directly connected.
Connected is like a direct link, then just a cable
and,
touching
and
it.
it requires a interface that has an IP address configured. The reason that route was installed is because I applied an IP address to gigabit Ethernet 0003, so on and so forth. You can see that they connected, and then what we're calling local here are more specific, right? Because local is owned by the router, so on and so forth. But yeah, so let's go ahead and create a static route super quick. Let's say, where do I want to go? Where do I want to go? Looking at our little, from router 1, let's say I want to get to 242.0/24. We're going to go ahead and config T, IP route, 2.4.2.0. Then you define the subnet mask, right?
And can you do /24 there, or do you have to type out the?
You do have to type it out, is my understanding. Some vendors are a little more relaxed about it, but Cisco, as far as I'm aware, with this iOS version we're running, is going to require it. And then it's going to want a forwarding router's address. So if I wanted to get to 2420 from router 1, I could either go to 1212 right here, sorry, or I could go this path right here, right? So let's just go to router 4. That's my favorite router. 1414, it looks like. 1.4.1.4. Wow. This isn't going to work. Just a little sneak peek. Let me go ahead and scoot that over. This configuration isn't going to work by default because router 4 also needs to be configured to have a static route back to router 1 in order to, well, it depends on the interface, I guess, that you use to send that packet.
So statics aren't a one-way street. You have to have both lanes.
Yeah, that's where it gets super frustrating. Static routes are very manual. I'm sure anyone who's had to make a bunch of static routes is understanding where I'm coming from. But every router within this, we only have 4 routers. And in order for router 3 to learn about every prefix in this, I'd have to create 1, 2, 3 static routes.
That seems with the amount of logic they have that is like magic behind the scenes on the routers. It seems that's one that, like, why can't they have it, like, if you create a static route to another router, why can't they just have it automatically connect back? That feels like one that, with everything that they do magically.
There is a lot of, if I create a static route, you can redistribute it via routing protocol, but if you're already using a routing protocol, especially in one small network like this, so redistributing a static route that it already learned about via like let's say OSPF, no router is going to take that. You can redistribute it, but yeah, you have to already have automation like routing protocols in order to get more automation out of it, which is kind of funny. But static routes are the only static route you're probably ever going to use if you're going to configure one is the default route at your border, right? So if you have one router that connects back to your firewall, or maybe even your firewall, you may have noticed that when you obtained an IP address from your ISP, you got a default route back to that ISP that is installed via DHCP option 3, I believe. But anyways, that's the only static route I would worry about. Static routes are kind of difficult to manage, very easy to configure, but difficult to manage, right? So the next type of routing is dynamic routing. And what do we mean by dynamic routing? Well, we kind of have to break down like what types of dynamic routing there are. We've got so distance vector routing protocols like RIP, unfortunately, but distance vector routing protocols have no visibility past their neighbors in terms of do you see how we see this network topology as it is, right? And we can see every single router in this topology. Let's say we're router 3 from this perspective, right? If we were running RIP by neighborship, it would only see router 4 within its topology. So you'd almost have to pretend that you could only see, if you're router 3, router 4, right? It's aware of all the routes if you have RIP enabled everywhere, but it's trusting that router 4 has configured or is sending those prefixes trusted. It's called routing by rumor is what I believe they call it. But disinfector routing protocols really don't know the entire network topology. But their resources are super light, which is why a lot of very lightweight routers would prefer to use RIP over, let's say, something like OSPF, right? But
So if you're using disinfector and say you're on router 1 looking to get to router 3, there's no way you know that it's going just straight to 4 down to 3, the fastest path. That might go up through router 2 first.
no, that's not necessarily true. You're just assuming that router 4 is connected to router 3. You have no idea if router 3 even exists. You know what I mean?
Okay, so it says
So if you're using RIP, the way I didn't have RIP in here, but we can quickly go into the metric. It's by hop count. So in this case, it would be what, 1, 2, 1, 2, 3. So yeah, it would take router 4 always, just based on the metric.
so switches don't count as hops; it only counts routers. You said it was 2 versus 3.
Yeah, so we've got from router. So if I wanted to go from router 1 to router 3, if I went through router 2 to router 4 to router 3, that's more hops than router 1 to router 4 to router 3, right? So that's how RIP would identify that. That's a better path. But the disadvantage to RIP compared to other routing protocols is it is hops. Let's say that this link in the middle here, 1.4.1.0, is a 100 kilobit, or let's say T1, right? And then your link from router 1 to router 2 to router 4 is all gigabit. It will only identify hop and still send traffic that way, even though you wouldn't call that the most beneficial path to use, right? So that's where link state routing protocols are the cream of the crop. They have full network visibility. The way you see this topology is almost how you could pretend to understand how OSPF sees this topology. You could kind of see it like this, right? Maybe not one-to-one, but
So link state, it's not just hops, but it can also see the actual link speeds between them as well.
yes, yeah. So every link has a bandwidth metric within OSPF. We're kind of talking link state, but the only link state routing protocol that the CCNA really wants you to know is OSPF. So that's kind of what we're doing. Yes, every link has a metric, and it's added as as OSPF builds what they call, it's kind of funny, it's a spanning tree, just like spanning tree, but it's a tree of paths basically. And when it calculates every path to that router, the metric is added, and then using that metric, the router determines the best path. So it's not necessarily hops, it's just the bandwidth determines the metric, which then determines the actual value of that link.
It gives you a computer score that we don't have to understand.
Exactly. Well, yeah. So the other advantage to link state routing protocols is they have partial routing updates. I didn't bring this up in Disinfector, and I apologize. Disinfector will send the entire routing information table to its neighbors, even though the neighbor already has that information in its routing table. It's very and it does it periodically. It doesn't do it when triggered. It does it every 30 seconds, 60 seconds, right? So, I mean, if that's not an issue, it's really not a big deal, but that's a lot of network traffic moving over your links when it's really not required, right? Whereas link state has the advantage of only sending partial routing updates. So if a route is lost to a router, it will only remove that route or notify its neighbors about the removal of that route. And then they don't have to touch any other routes, right? And additionally, it's only sent when that route is actually lost. It's not sent in a periodic interval, right? But it is way more resource intensive to build these trees of links. It requires a lot more resources. But I mean, in 2022, resource consumption is kind of, I don't know. It's if you're using a Raspberry Pi as your router, then you might have an issue. But if you buy an actual vendor and you implement OSPF, they do have scalability issues, but you're probably not going to notice it if you design it correctly.
So it's following the trend of most technology. When it first came out there, you had to have the best equipment, spend a bunch of money, but as time goes, it just almost anyone can get it now as long as they do the setup.
Right. OSPF isn't too intense. We use catalyst switches here for our routers per se that hosts can see, and it doesn't use that many compute resources. It's not too bad. So we kind of already got into this, but we have to interpret the components of a routing table, let's go ahead and just reopen router 1 super quick. I hope you're not falling asleep on me. This is all CCNA material. Yeah, yeah.
Gotta prep for the test, man.
That's right. You want to make buku bucks? Don't become a network engineer. Go into what is it? Project management. There you go. So we already talked about the routing protocol code, but we'll go ahead and just redefine that super quick. So that routing protocol code is that C and L on the far left side. I can go ahead and try to highlight it again. Right here. Yep, missed it, but that's okay.
You're close though.
I was super close. The prefix of a route is right here, right? Easy money. The next hop, let's use the one we created. The next hop in this case is this via with an IP address. And then the administrative distance. Okay, that's kind of something we have to talk about. I don't really have the picture pulled up, but let's imagine this. You're a router. How do you trust different routing protocols and different methods of learning a route, right? You define like a cost to it. The cost is defined internally. So a Cisco router will prefer a directly connected link over a static route. But a static route is preferred over OSPF. But OSPF is not preferred over EIGRP. These are all things you could look up. If you just look up administrative distance Cisco, there's a table with all of the metrics there. But that's just how the router itself prioritizes routes, right? Of course, you want to trust a directly connected link because that is directly connected. Why? If you learn that route via OSPF, why would you use that, right? But it's almost like a trust thing too, I guess you could say. And you also have metric. Every routing protocol has a metric like we were talking about. OSPF uses the bandwidth of the link per OSPF neighbor, I guess you could say, to define the metric, and then it adds it up on the entire path to a router. So that's the metric. It will be displayed here.
So the administrative distance is a part of the overall metric, but not.
They are two separate things.
Okay.
So do you see here, if we're looking at that you see this 1/0 right there? So the administrative distance is on the left, which identifies that it has an AD of 1. And the metric that the routing protocol has defined is 0, but it's a static route, so there is no metric, right? But like if we were running RIP, the metric would be how many hops away is this, right? If we were running OSPF, it would be how expensive is the path to get to this prefix, right? In terms of bandwidth. EIGRP, yeah, there's like 5 what they call K values. You go ahead and look them up. It's basically how the router itself determines the best path. Okay. You don't necessarily have to like look at the metric and be like, that I got to remember that. You just got to know that what these two numbers actually mean from left and right. Because what they might do is they might be like, what's this number on the left? What does that identify? Is that administrative distance? Is that metric? And they just want you to be able to be like, that's administrative distance.
So it's a CCNA information that you don't really use in real life, but you have to know it for the test?
Yes, I would say so. I think modifying metrics within routing protocols is pretty common, but administrative distance is only used for what they call a floating static route. But we'll get into that here momentarily. The gateway of last resort, I did not have one set because I really don't have a gateway of last resort in this little app, but it's usually defined right there. It's going to be I believe it, I've never used anything less broad than the actual default route, 000/0. So usually that'll display up there and it'll give you who the next hop is to get there.
It's just kind of the catch-all. If it routing table misses it, it just goes there.
Yeah, exactly. Okay, so we have to determine how a router makes a routing decision by default. How are we on time? Are we doing okay?
Yeah, we're doing okay. You can take a question whenever you want.
Yeah, I'll go ahead and we can take a question. This is a good pause for a second.
All right, guys, what is your recipe against ransomware? Sincerely, Marcel.
I wish Bobby was here. Bobby, are you here?
Bobby.
So because I've been doing the Patch Tuesdays for a while,
Yeah.
and it seems to me more often than something that's a wormable where they don't need user access is the biggest exploit is the user clicks on something they shouldn't.
Yeah.
So the number one ransomware is trade your people.
Right.
Other than that, I mean, is there anything within the network you can do outside of having your workforce on guard?
It's really endpoint protection. That's the biggest advice that if you're using your network to protect your endpoints when you could just be using endpoint protection to protect your endpoints, I think that's really where you have to focus. There is like UTM features within firewalls and stuff, but proper endpoint protection is definitely absolutely required. But the recipe, we have a very skilled security engineer who works here, and he has the details, but I believe he's not here right now. So
We may hear from him in a couple of weeks.
Oh,
We're
really?
hoping to do kind of a security audit type of webcast.
Perfect.
So, Bobby doesn't know this yet because he's out this week. But,
well, there you go.
He's been volunteered.
Bobby, if you're listening, you know. But yeah, should we do one more or
yeah, if you'd like.
let's do it?
Kind of somewhat related, but not exactly related. PDQ Central Server, MTU, DF bit packet fragmentation. I have issues where the admin client will not connect to the central server. Wireshark indicates packet fragmentation issue. Sincerely, Paul J.
Apparently, you've made him excited.
Yeah, you probably need to on the router that faces that PDQ Central server, you need to probably lower the MTU value, or actually I would do it on the client even, or you can do what's called MSS clamping on whether you're doing an SVI or the interface that faces your clients, like let's say you're using VLAN 2 and that's where the server exists. You can do what's called MSS clamping, which takes the TCP header and makes sure it's a specific size that you set, right? Which will make your MTU lower, right? Because if your MSS is lower, then everything underneath MSS from layer 5, 6, 7 will be lower, therefore making your MTU lower, if I'm making any sense.
Yeah,
But
so in one of the early webcasts, you covered MTU on unless you're in like a server farm, change the MTU is not best practice. Is this a case where the MTU maybe wasn't changed, but for some reason it still just needs to be shrunk below the default?
maybe
or?
the MTU is being adjusted by, or maybe it's being increased too much by, like, let's say an IPsec tunnel, right? Or let's say like a GRE tunnel or whatever. Anything that adds a header to your packet, and then on top of everything else you've got going underneath there, yeah, you're going to run into, even if you're using a default 1500, you may have it be way too much, or over 1500 or 1514 if you want to get super specific. But yeah, what I would do is what I would do right now, if somebody came to me here at PDQ and said we're having issues with this, is I would MSS clamp that subnet, because it's easier to do from my desk and drink a monster. So I don't have to go to every client and adjust the MTU. When they open a TCP connection, they will be forced to have a certain MSS size, which will adjust your MTU value. So I hope that helps. I'm super sorry if that's not helpful. And we can break it down. I will type it out in any way if you need it. So
I don't get it.
that's okay. That's okay. I hope the MSS clamping, that should get you within documentation to whatever vendor you need, or just adjusting the MTU on both clients if you need to. But that's very manual work.
So, Jake, we don't have to get it. That's what we have Austin for.
That's right.
There you go. There you go. All right. If we're still good on time, I can keep moving.
Yep.
Keep going.
Okay. So how does a router make a routing decision? Oh, wow. Really getting philosophical today, right? Let's talk about longest match, right? We talked about administrative distance and how a route is installed in the routing table. So right now, if I was running OSPF and I enabled it for the link that goes to 2420 and I created a static route, the static route would be preferred because it has a lower administrative distance, right? If I if I ran EIGRP and OSPF and enabled it for 2420, EIGRP would be preferred because it has a lower administrative distance, right? But that's if the prefix or the longest match is the same. So what am I saying with that, right? What I'm saying is when you have a subnet mask in a routing table, the router will always prefer the longest match to the subnet. So if do you see how we have a /24 here in the static route we created for 2420? Let's say I config T. Oh, come back, please. Config T. We'll just cheat and do a little bit of up. Oh, I did sticky keys. My bad. Please don't judge me. So we're going to cheat a little bit and do 1 2 1 2 1 2, I believe. But we're going to be just a little bit more specific and say...
So not a full Class C then?
Right, not a full /24, right? Because we're not doing, I believe it's class... I always confuse classless and classful, but we're not using the classes, right? I think it's classless. But let's go ahead and do that. So I believe if we look at our routing table, we've got two static routes, right? If I wanted to get to 2422, I believe, which is this guy right here.
The switch, yeah.
That's this guy right here. If I wanted to reach that interface, how would the router decide how to get there? I've got two valid routes, right, to reach that IP address. Well, let's talk about it. It's that longest prefix thing I was talking about, right? Where the more specific route will always be chosen. So if we're looking at these two static routes, which one would be chosen? It's the more.
So longest prefix is just a fancy way to say subnet mask?
Yeah, it's the bigger subnet mask. That's the easiest way to describe it. So the bigger subnet mask in this case is the /25. So if I did a show IP route 1.2.1. Or I believe it's, did I get that wrong?
It's
Let's see.
on your routing
242.
table, right?
Yeah. Excuse me, 2.4.2.2. It's going to take the more specific path that we had chosen, even though that both of those are valid. You have to understand that the more specific route will always be chosen by the router. And this is another good command. You don't have to just do show IP route. You can do the IP address if you really, really want to know specifically where the router would send that packet. So longest match is how they get you. They're going to be like, which route will be preferred? Is it OSPF with a subnet mask of /28, or is it EIGRP with a subnet mask of /24? Even though EIGRP has a lower administrative distance, it isn't more specific. Therefore, the OSPF route will be preferred. Do you know what I mean?
Yep.
So remember that one.
It feels like a lot of the CCNA questions are more of a test to if you catch the gotchas than if you know the information.
Yeah, I guess they assume people have run into this a lot. I mean, you see it. It's good information to know, right?
Yeah.
But it's associate level stuff. It's like you just got to know like the difference between like why does a router pick a route?
Yeah.
Let's break it down mentally. Sounds good.
Right.
And the routing protocol metric we already talked about, so that can be the end for sure. Hopefully that was informative for you.
We got questions, I think.
Yeah.
Yeah, we have a couple questions. They may not be directly related, but let's take them anyway. Hey guys, should we consider allowing Chrome deployments package to skip the auto update step 3 with a lack of PDQ agent and offline PCs were potentially less secure without auto update?
I mean, I'd say especially with the issues with all Chromium-based browsers have been having some aggressive updates recently. One that got a CISO alert.
Oh, really?
Yeah, so definitely those are ones you want to keep up to date. If you're losing access to them and you can't reliably update those from PDQ, then absolutely disabling that is your best option because it's better to stay up to date any way possible than to just lock on to your preferred method.
Exactly. I say yes. Whatever Jordan just said, you should do.
Good call. And our final question today, we have users that are working from home and sometimes they do not connect to the VPN. Shame on them, by the way. Is there a way or PDQ client to see them in inventory? Danny M.
So, as far if they're not connected to the VPN, PDQ, as it currently stands, can't. A while ago in the webcast, Lex and I built something where we built a custom field that had email address tied to the computer, and if it was shown as offline for over a certain amount of time, it would kick off an email saying, "Hey, connect to the VPN."
That's really good.
There's quite a bit of setup on that one, but it does work. That's the only way I can think of, and even then, that's not us connecting to it. That's you,
Prompting users.
yeah, prompting the users to connect to it.
Where can you find that?
It should be webcast. We'll have to go through and look it up.
Okay.
I hope it's a webcast and not just something I wrote for a customer. If it's not in webcast, I'll get it up in bonus content.
That's perfect. That sounds like, I mean, with the capabilities right now, that's the best you can do, right? Unfortunately. So.
All right. That's it's camera 2, I guess.
All right. Thanks for tuning in.
Yeah, thanks for having us.
I mean, routing, you said this was less time than the switching, but it seems like this is the more critical part for you to spend your time? Or?
It's just as critical. It's
just as critical. Oh, you don't want to...
I don't have a favorite child.
You don't want to label a favorite. All right. So hopefully this helps them get running with getting their network.
Correct. Yeah. I hope if you missed our last webcast, feel free to check out our other YouTube videos. You'll see my mug on there. Yeah.
For PDQ, I'm Jordan.
And I'm Austin. See you later.
Thanks for joining our webcast today. Congratulations, Danny M. and Paul J., winners of PDQ swag. Send us your info at webcast@pdq.com. If you like what you've seen today, feel free to check us out on YouTube, like and subscribe to that channel. Why don't you? It would make us smile. Have a fantastic week, and we'll see you back here next time.